In Studio 5000, when writing a program, we're not just writing a program. That's a little bit of a misnomer. We actually have multiple tiers within the project file, broken down into tasks, programs, and routines. Let's talk a little bit about what that means. When talking about tasks, programs, and routines, let's start from the bottom up, the routine. The routine is what actually contains the executable code in a program. That means the logic we write to make things happen. A program can have multiple routines. If we select a program and right-click and go to Add, we can insert a new routine. Let's call this one Box Counter. You'll notice the new routine Box Counter is inserted into our main program. If you look at these routines, you'll notice that main routine has a little icon with a 1 next to it. Any routine with this 1 icon on it is going to execute automatically. Any other routine will have to be called. Let's talk about how to call a routine. To run a routine that's not automatically scheduled to be run, like our main routine with the 1 icon located inside, we need a jump to subroutine instruction. So here in our main routine, I'm going to add a rung. Then I'm going to navigate over in my instruction palette to my Program Control tab. I'm going to select the jump to subroutine instruction and insert it. First thing it asks for is a routine name. I'm going to want to put the name of the routine that I would like to run in there. Now you'll see it gives me an option for input parameters and return parameters. Let's ignore those for a second. I'm not ready to talk about those yet. I'm just going to double click inside of here, hit enter, double click, hit enter, until those boxes go away. Now within my main routine, I have a simple instruction that calls my box counter routine. If I were to add another routine, let's say bottle counter, I could likewise call this routine from my main routine. Rather than reinsert a JSR instruction, I'm just going to copy this rung and change the routine to my bottle counter routine. Incidentally, it's very common programming practice for the main routine to perform little other logic other than to call the other subroutines. That's a fairly standard programming practice in the industry. Doesn't mean it's the only way you can do it, but it's the way it's generally recognized and accepted from the projects that I've worked on. Just like we can have multiple routines within a program, we can have multiple programs underneath a task. Same way you have chapters in books and books in libraries. It's just a different way to further subdivide the logic you're writing to chop it into little bite-sized pieces and make sense. Let's add a new program to our main task. If I right-click on main task, I can add new program, call it whatever I want, and now I have 2 programs beneath my main task. Under my other program, I can add additional routines. And you'll notice that the first routine I add has this little number 1 icon, meaning that it's automatically scanned by this program. So we just discussed how when we add additional routines into a program, we need to put instructions in our main routine in order to call those programs. In this case, our jump to subroutine instructions. Well, when we add a program, how do we call a program from a task? These 2 programs are inside of my main task. If I right-click on main task and go to properties, you can see a tab here called Program Schedule. In my program schedule, I can see that both my main program and my newly added program are scheduled. What does scheduled mean? Scheduled means that they are going to run when the processor is running. I can change the order that they run in with these arrows, or I can select a program and remove it from my scheduled list and place it in my unscheduled list. What does unscheduled mean? Unscheduled means that when the processor is running, that program and its routines will not run. If I were to click Apply and OK, I can see that this program, now that it's unscheduled, lives under this unscheduled folder rather than up here with my scheduled items. When we start talking about scheduled programs and unscheduled programs, it kind of begs the question, why have an unscheduled program? Why would we want code in our processor that never runs? Well, two possible examples might be features that the customer could buy or different configurations. Let's say we have a product line and we sell 100, 1,000 of this product a year. And the product could come in configuration 1 or configuration 2. And depending on whether the customer purchases it, it could have certain operational upgrades or data logging features. I've added some programs here into my main task. If I go into my main task and into my properties, if a customer buys a machine using machine configuration 1, I may want to remove the code for machine configuration 2 so it doesn't conflict. And if they don't give me money for my data logging or my operational upgrades, then I can remove that from the code that executes in the processor. Click Apply, and I see these particular items are unscheduled, but in my scheduled items up here under my main task, I have my machine configuration 1. Later on down the road, that customer could call up and say, I would prefer to give you a few $1,000s a month for my data logging. Okay? I can add that into my scheduled programs, and they can be up and running as soon as they send me the check. So if routines contain executable code, and programs are groups of routines that share common data, what are tasks? Tasks are a mechanism for scheduling and executing programs. They determine how and when code is executed. Tasks can be of one of three types: continuous, periodic, or event-driven. Continuous tasks, it kind of goes without saying, run continuously. They begin automatically and they execute through their programs and their routines, and when they're finished, they start back over again and go on and on and on and repeat. There can only be one continuous task in a program. And when we create a program, the first task defaults to continuous. If we right-click on our main task and go to Properties and Configuration, we can see that it defaulted to type continuous. Now, different tasks have different priorities that you can set, and higher priority tasks can interrupt a continuous task. In fact, the continuous task is the lowest priority task. We'll talk about task prioritization in a little bit. If I wanted to set up a periodic task, I would go to my Tasks folder, right-click, and select New Task. Give the task a meaningful name, and then from the Type drop-down box, select Periodic. The period is how often I want this task to execute. When the period expires, the program will interrupt whatever lower priority task it's working on, execute the periodic task once, and then go back to what it was doing. So if I wanted this task to execute once a second, I would set it at 1,000 milliseconds, and then I set the priority of this task. You can see here a lower number yields a higher priority, just like everything else in life. If I want this to be the highest priority task, I would set a 1. If I want it to be lower, I would increase the number to whatever. The watchdog timer keeps an eye on how long the periodic task takes to execute. If it takes longer than the watchdog timer, a major controller fault will occur. And that's to make sure that other tasks aren't interrupted too long. Then click OK. We can see the other task appear down here in our task list. Event tasks are set up to run once whenever a specific thing happens. Maybe a sensor gets blocked when a part is in place, or maybe an actuator is in the process of moving out of range and has to be stopped. An event task is a lot like a periodic task in that it will interrupt lower priority tasks, run once, and then let the code get back to whatever it was doing. But unlike a periodic task, it doesn't run on a time interval, it runs when something occurs. If we go to New Task, enter a descriptive name, and select Event, we can select our trigger. Our trigger is whatever causes the event task to run. We can see it could be an event instruction that's located in our code, some access registrations or data state change from a module input, or maybe a consumed tag changes. We can set our priority and our watchdog in exactly the same way as our periodic task.